This is acoustical engineering. Have you ever wondered why cars sound the way they do, or how noise-cancelling headphones work? Welcome to the world of acoustical engineering. Designing products that are quiet or sound great does not happen by chance, but involves the expertise and dedication of acoustical engineers working in collaboration with other professionals in a design team. To train as an acoustical engineer, you will need to develop specialist expertise in how sound is generated, by vibrating structures, for example, and how to control it. This often requires sophisticated computational models and experimental techniques, underpinned, crucially, by a fundamental understanding of the physics. You'll also need to study many of the subjects that mechanical and aeronautical engineers do, such as materials, fluid dynamics, and computer programming, as well as developing business acumen and communication skills, so that you are a well-rounded professional engineer on graduation. If you study acoustical engineering at Southampton, you'll have access to state-of-the-art facilities such as this and be taught by international experts in their fields, each with their own research areas that you can get involved with through student projects. For example, I have recently proposed group design projects on the removal of ice from aircraft wings using acoustics and the use of drones to transport medicines. Our graduates are highly sought after by a wide range of employers, ranging from consultancy companies who provide acoustic services to architects and town planners, for example, aircraft and automotive manufacturers, and the defence sector. If, like me, you enjoy solving problems that are directly relevant to industry and have the potential to improve people's lives, then explore the world of acoustical engineering.
Let's talk about aeronautical and astronautical engineering. Aeronautical and astronautical engineering is all about the science, engineering, and design of systems that interact with the Earth's atmosphere and outer space. So this includes flying aircraft, like jets, helicopters, and drones, all the way to spacecraft, rockets, and satellites. But it also includes other applications, like wind engineering to estimate loads on skyscrapers, designing wind turbines for green energy, and the aerodynamics of race cars. We aim to empower the next generation of engineers to push conventional thinking to provide more sustainable, ethical, and people-centered solutions to tomorrow's engineering challenges. Our courses provide a solid foundation in the fundamentals of engineering, but also allow students to specialize in aerospace-specific topics, supported by our extensive facilities that include a professional manufacturing center, the largest wind tunnel in any UK university, state-of-the-art space propulsion lab, our high-performance computing facilities, and our Boeing flight simulator. Our students get hands-on experience through individual and group projects, getting the chance to work with our academics on their world-leading research, as well as through our student teams, such as the Formula Student Race Car, CubeSat, and Human-Powered Aircraft, helping students to develop the skills required to become successful engineers in aerospace and automotive industries. I teach on optional modules in the aerodynamics theme, on turbulence and wind tunnel testing, and I enjoy sharing our latest research with students in my lectures, and to inspire them to push the boundaries of knowledge and what we're capable of. It is really satisfying seeing our students graduate and go on to successful careers in research or industry, working for names you'll recognize such as Airbus, the European Space Agency, Formula One teams. With support from our careers teams, you could choose to do a summer internship or industrial placement year and find out what the future might hold for you.
Welcome to Civil Engineering! Engineers use their knowledge and imagination to create the world around us. If you think about the place we live and work, it's civil engineers who design and construct them. If you think about the infrastructure, the system that provide energy, water, food and transport, it's civil engineers who design and construct them too. What is unique about civil engineering at Southampton? Firstly, we let you follow your passion. Our course has many options and pathways to help you become the engineer you want to be. from structure, environment, transport, water to energy. Secondly, we have a new engineering campus with amazing workshop and lab, like here at the National Infrastructure Lab, where you will get hands-on and learn by doing. We will make sure you are career ready. The design project in each year train you to think like a civil engineer, starting with a constructorium in year 1. This is a week-long residential where you and your team will build a large-scale construction, such as a bridge that you can walk on. We also have the Success Scheme to help you find the right employer through summer jobs with a top-up scholarship. This career kickstart means most of our students have a job lined up by the start of the final year. Finally, our engineering program gives you future-proof skills, digital skills in particular, but also teamwork and leadership skills. So civil engineering at Southampton can take you many places. You might end up designing a huge wind turbine in the ocean, the new water and transport network to make towns and cities more livable, or sustainable building resilient to climate change. Whatever path you choose, we will give you the skill needed to engineer a sustainable world.
Welcome to Maritime Engineering. Maritime engineering is important for all aspects of our lives. Global trade relies on ships to transport food and goods. We generate energy at sea. The internet only works because of hundreds of subsea cables. The maritime industry is changing faster than ever to combat climate change and meet government targets like net zero carbon emissions by 2050. We need young engineers to help develop innovative technology and design solutions for the future. Our students are helping pave the way for a more sustainable maritime future through improving efficiency and harnessing new energy sources in ship design, designing maritime renewable energy technologies, developing innovative low-emission high-speed craft and autonomous robotic systems. We're taking technology from the America's Cup, such as wing sails and hydrofoils, to propel the ships of the future and reduce their drag. While studying maritime engineering, you'll develop your technical, creative and interpersonal skills and get hands-on experience using our 138-metre towing tank, the largest of any UK university, alongside wind tunnels, engineering labs and professional manufacturing facilities. We believe you learn best by applying knowledge to practical problems, so we offer essential lab classes in the towing tank in every year of the degree. You'll learn to work with people as part of a team through project work solving real-world problems. When you graduate from maritime engineering, you'll have a broad-based engineering degree accredited by 3 governing bodies, so your career can include mechanical engineering, marine engineering and naval architecture. This keeps your options open whilst making sure you have all the maritime-specific knowledge required to help transform the maritime sector in the future.
Let me tell you about mechanical engineering. Mechanical engineering is about understanding the fundamental physics of objects and systems that are often in motion, and then taking that understanding and using it to design new products and technologies, such as cars, aircraft, satellites, robots, and so much more. One of the great things about mechanical engineering is that it is a broad subject, one of the most general of the engineering disciplines. With a degree in mechanical engineering, you can take your career in a huge and truly diverse range of directions. Automotive, biomedicine, energy, acoustics, aerospace, robotics, and many, many more. You find mechanical engineers everywhere. One of the things we pride ourselves in at Southampton is that we believe in learning by doing. So our students do not just learn about the academic fundamentals of engineering, they also get their hands dirty applying it, designing, fabricating and testing. This approach runs through our courses from the very first week that you arrive at university to the last thing you do just before your graduation. We're a research-led university, one of the foremost places in the UK for engineering research, and this feeds into our teaching. When you study at Southampton, you'll be taught by world-leading experts who bring their latest research into the classroom. In projects and later years, you get opportunities to access our world-class research facilities, such as our materials testing labs, electron microscopes, X-ray imaging suite, wind tunnels, and supercomputers. Once you join mechanical engineering at Southampton, you become part of our community, and it's always amazing keeping in touch with our alumni to find out what's next in their journey. An undergraduate degree in mechanical engineering opens the door to destinations including further study, such as PhDs, research and development in industry, and entrepreneurial endeavours such as starting a company. You can quite literally engineer your future.
Want to know about medical engineering? Medical engineering is about enabling people to live healthier, happier, and independent lives for longer. Medical engineers design, develop, and deliver products to patients, carers, and clinicians. These healthcare products can provide positive change to people that need it the most, from diagnostic equipment to identify problems or monitor recovery, to internal body part replacements such as hip joints or cochlear implants, all the way through to the humble sticky plaster. At Southampton, we have a long history of bioengineering, and for decades have had a dedicated theme on our mechanical engineering pathway. In response to demand, we now have our medical engineering degree, which enables us to train mechanical engineers and allow for an immediate focus on the application of mechanical engineering to helping solve healthcare problems. Our courses offer training with a focus on user interaction and needs to develop technologies that includes a wide range of professionals such as doctors, nurses, physiotherapists, and occupational therapists. We constantly research a wide range of projects, and our students take part in group activities and have even developed equipment for Paralympic sports. Medical engineering graduates are in high demand as they have the skills required to work across the healthcare technology sector, from small and large medtech companies to throughout the NHS. If you have a passion for people and engineering, then medical engineering provides a platform for you to make a positive difference to those that need it most.
Welcome to Aerospace Electronic Engineering. Engineering is changing. The traditional boundaries between disciplines are beginning to blur. This is especially apparent in aerospace systems, including fixed-wing aircraft, drones and missiles, where enhanced capability is partly attributable to the onboard electronics found in many of these systems. Precision guidance, autonomy and the use of network battle systems are all possible due to the advances made in electronic and control systems, which have rapidly developed over recent years. Engine management, detection and management of system faults and reconfiguration due to component failure or external damage are again all possible due to electronic systems. The degree in Aerospace Electronic Engineering at Southampton aims to equip students to meet current and future needs for graduates who are well versed in electronics, as well as more traditional aerospace engineering concepts. It strikes a balance between the study of electronics and software, as well as subjects such as mechanics and flight dynamics. Students studying here benefit from knowledgeable and enthusiastic staff, state-of-the-art lab facilities, and a wide choice in third and fourth year optional modules. The final 2 years also enable students to develop their own independent research interests through both individual and group projects. Examples include the design of a rocket thrust vectoring system, AI-enabled control systems, and various projects involving the design and build of drones. I teach the 4th year nonlinear control of aerospace systems. I really enjoy teaching the course because it blends elegant theory with engineering practice. It offers a glimpse of how advanced aircraft control systems are beginning to be designed and how the approaches will develop in the future. I draw on my own research experience And it is great to see those eureka moments when students really understand the concepts I'm trying to convey. If you have an interest in and an aptitude for aerospace systems and electronics, then our degree could be an excellent start to your career.
This is Biomedical Engineering. I'm excited to introduce you to the fascinating world of biomedical engineering. This multidisciplinary field combines principles of engineering with biological and medical sciences to improve healthcare. Biomedical engineering is crucial because it leads to life-saving technologies and improved healthcare systems, impacting the world and our everyday lives. At the University of Southampton, we offer state-of-the-art laboratories and research centers for designing and developing medical devices, biosensing and diagnostic tools, healthcare digitalization, and biomedical signal processing and machine learning. Our curriculum mixes theoretical knowledge with practical skills, supported by various research groups for hands-on projects. What makes our program most special is the freedom to choose from 4 pathways: artificial intelligence, digital health, electronic systems, and mechatronics for health. This flexibility lets you to tailor your education to your interest and career goals as you learn more about biomedical engineering in Southampton. Within our biomedical engineering program, you can find yourself working on projects such as developing artificial intelligence systems for drug discovery, digitizing the physical world to enhance patient care, and designing sensors for disease diagnosis. After graduation, you have diverse working options, such as working in the medical device industry, hospitals, biotech and pharmaceutical companies, research institutions, and regulatory agencies. We also offer advanced research opportunities and support for aspiring entrepreneurs through our Startup Accelerator. I'm passionate about teaching the subject because it contributes to life-saving technologies and improved healthcare systems. It's incredibly rewarding to see students grow into skilled professionals and make a real-world impact.
This is computer engineering. From small technology to large networks, computer engineering impacts our everyday lives. Computer engineering combines programming and maths from computer science with transistors and logic gates from electronic engineering, and then we use them to create computers and computer systems. That includes designing digital hardware such as CPUs or GPUs, writing software and optimizing algorithms, all the way up to designing and implementing complete systems like self-driving cars. Because computer engineers understand the full computing stack, we can solve problems in multiple ways. Sometimes that solution is pure software, sometimes we might design a custom hardware accelerator, but often the best solution combines knowledge and skills from both software and hardware. This is particularly true as we move towards more sustainable computer systems, as co-designing hardware and software together can provide both higher performance and lower energy consumption. Our School of Electronics and Computer Science is a particularly good place to study computer engineering, as we have world-leading academic researchers and facilities for both electronics and computer science, and everything in between. For example, we fabricate cutting-edge chips in our clean room, and our Iridis Compute facility is one of the largest in the UK. We also offer a range of 3rd and 4th year options from across computer engineering, computer science, electronic engineering, and have excellent links with industrial partners from across the engineering spectrum. Whatever your career goal in computer engineering is, we can help you customise your learning journey and develop the knowledge and skills to achieve it.
Let me tell you about electronic and electrical engineering. I'd like to introduce you to the wonderful world of electrical and electronic engineering here at Southampton. Electricity is such an important part of modern life. Our world is built on electrical and electronic technologies developed by highly skilled engineers. Electrical engineering is about the generation, storage and transmission and use of electrical power. So think your high voltages and your large currents. Imagine smart grids powered by cutting-edge wind turbine and solar panel technologies. Electronic engineering deals with low voltages and smaller currents, with a focus on hardware and its control through software, from the microchips within your phone to the electronic systems in the latest generation of electric vehicles. I'm thrilled to research and teach in this area, as I see it as the key to tackling many of the big challenges we face as a society. For example, on the challenge of climate change, electrical and electronic engineers are developing new ways to harvest energy around us, such as powering wearable techs from your very own body heat. Another example is in disaster relief, where electrical and electronic engineers are developing autonomous aerial drones and smart software to help coordinate the emergency response. It's this connection with solving real-world problems that really excites me. I can make a real positive difference and improve people's lives. At our School of Electronics and Computer Science, or ECS, we offer a variety of degrees that you can tailor through a huge range of optional module choices, learn theory and practice this hands-on in our world-class labs such as these. There is a strong demand for electrical and electronic engineers, and our students have gone on to further study and research, as well as working for big names such as Jaguar Land Rover, Nike, IBM, and even set up their own businesses.
This is mechatronic engineering. Mechatronics touches our everyday lives through devices such as smartphones, washing machines and thermostats. Mechatronic engineering is a multidisciplinary subject which covers the intersection of mechanics, electrical systems, electronics and computing to create simpler, more economical and more reliable systems. Areas of study are guided by active research in areas such as wearables and haptic devices, meaning devices that use touch, such as robotics, electromechanical devices, mobile devices, power recovery and energy harvesting. Here at the University of Southampton, our mechatronic engineering program covers a wide range of traditional and innovative technologies with the potential to contribute to the design of intuitive and safe interfaces between humans and mechatronic systems, such as stroke rehabilitation using functional electrical stimulation. Southampton has a world-class reputation for teaching electronics and computer science, and our multi-million-pound labs offer sector-leading capabilities and an unrivaled space for our undergraduate students. To support our third and fourth year students, we have a dedicated hardware projects laboratory with specialist technician support that includes a printed circuit board manufacturing area, 3D printers and laser cutters. I teach second year modules related to electrical machines, including the design. This includes the construction of simulations using commercial software to provide students with insight into operating principles of electrical machines. In later years, there are mechatronics modules relating to robotic systems, including biologically inspired robotics, and specialist modules covering power transmission and vibration in mechanical systems. Our students actively pursue their passion for mechatronics by attending and running activities and competitions through societies such as RoboSoc, the Robotic Society. Mechatronics students can apply for the IET Power Academy, which offers a bursary and summer placement throughout their degree. Graduates often go on to work for these companies, and our ECS Careers Hub has links with organizations such as Captech and BAE Systems. If you have an interest in designing and building tech, then Mechatronics offers you the opportunity to become a skilled engineer in this field.
Welcome to software engineering. Software engineering is like being a wizard of the digital world. You get to design, build, and fix software that makes our lives easier and more fun. Think about your favorite game, the app you use to chat with friends, or the software that runs robots. That's all made by software engineers. And it is not just about programming. Software engineering is also about working with people to solve real problems with innovative designs that can be transformative. Imagine creating software that keeps hackers out of our personal data, or developing AI that can help doctors diagnose diseases, or even building smart city tech that makes our cities greener and more livable. Amazing, isn't it? At the University of Southampton, we have amazing facilities and a really fine student life. We have cutting-edge teaching and independent study labs. And you will get hands-on experience from day one. Plus, we have awesome societies like the Electronics and Computer Science Society, the Cybersecurity Society, and Game Dev Society, where you can show off your skills and meet friends who love tech just as much as you do. Studying software engineering can lead to so many great jobs. You could become a game developer, a cybersecurity expert, or even start your own tech company. Our graduates have gone on to work for big names like Apple, Google, and Microsoft. Some even continue their studies to discover new things in the tech world. I just love teaching software engineering because it's a mix of creativity and solving problems. It's amazing to see students learn how to build something from scratch and watch their ideas come to life. At Southampton, you will be part of a community that's always pushing the limits of what's possible with technology.
Welcome to chemical engineering. Chemical engineering is all about combining the exciting elements of science to the real-world applications of engineering. If processes or products involve chemistry and are made at a large scale, then it's very likely a chemical engineer either designed or made it. And this is a lot broader than what you might initially think. It can be health-related products such as pills, tablets, capsules, syrups, or vaccines, or beauty products such as shampoos, soaps, or moisturizers. It can be drinks, including water, soft and alcoholic drinks, fuels such as petrol, diesel, natural gas. It can be electronic products, plastics, paints, glues, or chemicals. All of these involve chemistry and are made at a large scale. In addition to this, I think chemical engineering is crucial to address the main challenge of the 21st century. To me, this is a twofold challenge. On the one hand, we need to address the surge in demand for water, energy, food, and health-related products, which will come as our populations grow and increase their standards of living. At the same time, we're becoming acutely aware of the impact of human activities on the globe, whether through climate change or impact on ecosystems. And this means there's a phenomenal challenge in addressing surge in demand for all of these various areas while minimizing the impact of human activities. Chemical engineers are ideally placed to address this challenge because they'll be the ones that develop these new technologies and then roll them out at a global scale, which is the scale we need to address these problems. At Southampton, we're training our students in brand new state-of-the-art facilities and teach them how to think in a sustainable way. Our aim is for all of our graduates to help solve these and many other challenges over the course of their careers.